Hey there, fellow space cadets and physics fanatics. Ever look up at the night sky, see a sky full of stars and wonder, what's it all made of? Yeah, me too. It's a question that's haunted humans since we first learned to stare into the great unknown. And guess what? We're actually getting closer to an answer. How, you ask? Well, it's all thanks to a tiny little thing with a very big name, the Higgs boson. Yep, you heard that right. We're talking about the universe's most wanted, the VIP of the subatomic world, the one and only God particle. The Higgs boson is a fundamental particle, and it's kind of a big deal. Why? Because this little guy holds the key to understanding why things in our universe actually have, well, mass, so buckle up because things are about to get cosmic. Now let's get down to business. What exactly is this God particle everyone keeps talking about? The term itself is a bit of a misnomer, conjuring images of something mystical and otherworldly. But in reality, the God particle is just a nickname, albeit a catchy one, for the Higgs boson. Discovered in 2012 at the Large Hadron Collider, the world's most powerful particle accelerator, the Higgs boson sent shockwaves through the scientific community. The Higgs boson was the missing piece of the puzzle, the final frontier in our quest to understand the fundamental building blocks of the universe. For decades, physicists had relied on the standard model of particle physics, a framework that explains the fundamental forces in particles that make up everything we see and interact with. But there was a problem. It couldn't explain how particles actually acquired mass. That's where our little friend, the Higgs boson, comes in. But the story of the Higgs boson is about more than just one particle. It's about the thrill of scientific discovery, the power of human curiosity, and the never-ending quest to understand the universe and our place in it. We'll delve into the groundbreaking experiments at CERN, the European Organization for Nuclear Research, where scientists from around the world collaborated to build and operate the LHC. This colossal machine smashes particles together at nearly the speed of light, creating conditions that existed just moments after the Big Bang. It's like throwing a grand physics party where particles collide, new particles are born, and scientists eagerly collect data to unlock the secrets of the universe. So get ready to journey to the frontiers of knowledge where the infinitely small meets the unimaginably large. Alright, cosmic comrades, let's dive into the wild world of particle physics. The universe is like a giant Lego set, made up of tiny, indivisible particles called elementary particles. These are the rock stars of the subatomic world, each with unique properties. Physicists use the standard model to categorize all known fundamental particles and forces. It includes quarks, leptons, bosons, and gluons, names straight out of a sci-fi novel. For years, the standard model had this one nagging flaw, a mystery that kept physicists up at night. It couldn't explain one crucial thing: how particles actually acquired mass. The standard model was great at describing the properties of particles and how they interact, but when it came to explaining why they had mass, it just shrugged its shoulders and said, "Beats me." This missing piece of the puzzle, the origin of mass, became the holy grail of particle physics. Enter the Higgs boson, stage left. Now, to understand how the Higgs boson solves this mass mystery, we need to talk about the Higgs field. Imagine, if you will, a vast invisible field that permeates all of space and time. This is the Higgs field, and it's kind of a big deal. Think of the Higgs field as a cosmic mosh pit, a sea of energy that's constantly buzzing with activity. As particles move through this field, they interact with it, kind of like how you'd get jostled around in a crowd of people. The more a particle interacts with the Higgs field, the more massive it becomes. The Higgs field is the cosmic dance floor, and the Higgs boson is the music. Remember that cosmic mosh pit, the Higgs field? Well, the Higgs boson is like the ultimate mosh pit instigator, the one who gets the party started. It's the physical manifestation of the Higgs field, a ripple in this cosmic sea of energy. For decades, the Higgs boson was the missing piece of the standard model, the elusive guest of honor that physicists had been searching for but could never quite seem to find. That is until 2012, when scientists at CERN finally announced the discovery of a new particle that matched the theoretical predictions for the Higgs boson. The discovery of the Higgs boson wasn't just a random scientific breakthrough. It was the culmination of decades of theoretical work by brilliant minds like Peter Higgs, who first proposed the existence of the Higgs field and its associated boson back in the 1960s. Higgs, a soft-spoken Scottish physicist, never sought the limelight, yet his groundbreaking work revolutionized our understanding of the universe. He, along with other pioneering physicists like Francois Englert and Robert Brout, laid the theoretical foundations for the Higgs mechanism, a concept that would later earn them the Nobel Prize in Physics. Their insights paved the way for a generation of experimental physicists to embark on a quest to find the elusive Higgs boson, a quest that would eventually lead to the construction of the Large Hadron Collider. The discovery of the Higgs boson was a testament to the power of human curiosity, collaboration, and the relentless pursuit of knowledge. Okay, let's get our heads around this Higgs field thing. It's not exactly something you can see or touch, but trust me, it's there, lurking in the background of reality, like a cosmic stage manager orchestrating the grand dance of existence. Imagine a vast, invisible ocean stretching out in all directions, filling every nook and cranny of the universe. This ocean is the Higgs field, and just like a real ocean, it's constantly buzzing with energy, with waves and ripples propagating through it. Particles interact with this field, and it's this interaction that gives them their mass. Think of it like swimming through molasses. Some particles have a tough time making their way through, interacting strongly with the field and gaining a lot of mass. Now, when we talk about mass, we're not just talking about how much something weighs on a scale. Mass is a fundamental property of matter that determines how much inertia an object has, how much it resists changes in its motion. Think about pushing a shopping cart versus pushing a car. The car, with its much greater mass, is going to be a lot harder to get moving. And here's where the Higgs field comes in. It's the cosmic culprit behind inertia. The more a particle interacts with the Higgs field, the more mass it gains and the more inertia it has. Now let's talk about how this whole mass-giving process actually works. It's called the Higgs mechanism, and it's kind of like a cosmic dance party where the Higgs field sets the beat, and particles can't help but move to the groove. Imagine the Higgs field as a dance floor packed with dancers, and each dancer represents a Higgs boson. Some particles, like the elusive neutrinos, are like wallflowers, barely interacting with the dancers and gliding across the floor with ease. But other particles, like the top quark, are like the life of the party, bumping and grinding with every Higgs boson they encounter. This constant interaction slows them down, making them appear more massive. Now you might be thinking, okay, this Higgs field thing is pretty cool, but how does it affect me? Well, hold on to your hats because the Higgs field is essential for your very existence. Without the Higgs field, all particles would be zipping around at the speed of light like a bunch of cosmic race cars with no brakes. Atoms wouldn't form, stars wouldn't ignite, and you wouldn't be here reading this right now. The Higgs field is what allows particles to clump together and form the matter we see all around us, from the smallest grain of sand to the largest galaxy. So yeah, you can thank the Higgs field for your existence, and your cat's existence, and your morning coffee's existence, pretty much everything's existence. Now we've talked a lot about the Higgs field, but what about the Higgs boson? Remember, the Higgs boson is like a ripple in the Higgs field, a fleeting excitation that we can actually detect. Think of it like this. You can't see the wind, but you can see the leaves rustling in the trees or the waves crashing on the shore. Similarly, we can't directly observe the Higgs field, but we can observe the Higgs boson, which is like a tiny, fleeting glimpse into this invisible realm. Detecting the Higgs boson was no easy feat. It took the most powerful particle accelerator ever built, the Large Hadron Collider, to smash protons together at nearly the speed of light, creating conditions similar to those just moments after the Big Bang. And even then, the Higgs boson only sticks around for a fraction of a second before decaying into other particles. Alright folks, Buckle up because we're about to dive into the world's most epic game of atomic billiards, where the stakes are high, the players are tiny, and the prize is nothing less than unraveling the secrets of the universe. Enter the Large Hadron Collider, a behemoth of a machine buried deep beneath the French-Swiss border. This isn't your average science fair project. This is the world's largest and most powerful particle accelerator, a colossal testament to human ingenuity and our insatiable thirst for knowledge. Picture this, a 17-mile-long underground tunnel, a high-tech subterranean racetrack where protons, those positively charged particles hanging out in the heart of atoms, are whipped around at mind-boggling speeds approaching the speed of light. We're talking 99.9999991% the speed of light, folks. That's so fast that if these protons were racing Usain Bolt, they'd lap him roughly 7,500 times every second. Talk about leaving someone in the dust. Now, the Large Hadron Collider isn't just about giving protons a joyride. The real action happens when these tiny speed demons collide head-on in a shower of energy and subatomic particles. It's like smashing two watermelons together at supersonic speeds and then trying to figure out what all the flying bits and pieces are. These collisions are so energetic that they recreate conditions similar to those that existed just fractions of a second after the Big Bang. Talk about a blast from the past. And within this subatomic maelstrom, physicists hope to catch a fleeting glimpse of their most sought-after quarry, the Higgs boson. But finding the Higgs boson is like trying to find a needle in a haystack the size of a planet. Billions of collisions occur every second, and each collision produces a spray of particles that must be carefully analyzed. It's a monumental task that requires cutting-edge technology and the combined brainpower of thousands of physicists from around the world. But hey, who doesn't love a good challenge, especially when the fate of our understanding of the universe is at stake? For years, physicists at CERN worked tirelessly, collecting and analyzing data from trillions upon trillions of proton collisions. It was a monumental effort, a testament to human dedication, collaboration, and the power of a good cup of coffee. Then, in 2012, the moment they had all been waiting for finally arrived. Rumors began to circulate through the scientific community, whispered excitement building to a fever pitch. Could it be true? Had they finally found it? On July 4, 2012, scientists at CERN made a historic announcement. They had observed a new particle, a particle that matched the theoretical predictions for the long-sought-after Higgs boson. The data was clear, the evidence was compelling, and the champagne bottles were popped. The Higgs boson, the missing piece of the Standard Model, the key to understanding how particles acquire mass, had finally been found. The discovery of the Higgs boson sent shockwaves through the scientific community and beyond. It was a triumph of human ingenuity, a testament to the power of the scientific method, and a victory lap for fundamental physics. Newspapers around the world hailed the discovery with headlines proclaiming "God particle found" and "Higgs boson confirmed." The world was abuzz with excitement, eager to understand the significance of this groundbreaking finding. And what about the theorists who had laid the groundwork for this discovery? The visionaries who had dared to imagine the existence of the Higgs field and its elusive boson? Well, they were finally getting the recognition they deserved. In 2013, Peter Higgs and Francois Englert were awarded the Nobel Prize in Physics for their theoretical discovery of a mechanism that contributes to our understanding of the origin of massive subatomic particles. It was a fitting tribute to their groundbreaking work and a testament to the enduring power of theoretical physics. The discovery of the Higgs boson wasn't just a one-off event. It marked the beginning of a new era in particle physics. The LHC, once on a mission to find the Higgs, has now become a tool for exploring the universe's deepest mysteries. With the Higgs boson in hand, physicists have a powerful new tool for probing the fundamental nature of reality. They're using the LHC to search for new particles, to study the properties of the Higgs field in more detail, and to explore the mysteries of dark matter and dark energy. The LHC is like a giant microscope, allowing us to peer into the subatomic realm with greater precision than ever before. And with each new discovery, Each new piece of the puzzle, we're getting closer to understanding the universe and our place in it. But the LHC is more than just a machine. It's a symbol of human collaboration, a testament to our ability to come together and achieve great things. It's a reminder that when we put our minds together and dare to dream big, there's no limit to what we can accomplish. Okay, let's address the elephant in the room, or should I say, the deity in the particle accelerator, the whole God particle moniker. Now, before you start picturing physicists in lab coats bowing down to test tubes, let's clear the air. The term God particle isn't a scientific term, and it didn't originate in some hallowed halls of academia. It actually has a somewhat more, shall we say, earthly origin story. You see, the Higgs boson, while a rock star in the world of physics, was a notoriously elusive character, hiding out in the subatomic realm for decades, taunting physicists with its theoretical existence, but always staying just out of reach. It was a source of frustration, excitement, and endless speculation. Then, enter Leon Lederman, a Nobel Prize-winning physicist with a flair for words and a touch of mischievous humor. Lederman wrote a book about the Higgs boson, and he wanted a catchy title, something that would grab people's attention and convey the particle's importance and elusiveness. And thus, the term God particle was born, albeit with a slightly different phrasing initially. Section 2. Leon Lederman's linguistic leap from the goddamn particle to the God particle. Lederman's original title for his book wasn't fit for polite company. He wanted to call it The Goddamn Particle, capturing the frustration and awe of the Higgs boson, but his publisher suggested a slight modification to avoid backlash. So, the goddamn particle became the God particle, profoundly impacting public perception. The name stuck, becoming a media sensation and capturing the public's imagination. Section 3. A cosmic PR mishap, why some physicists cringed. While the term God particle generated buzz, not everyone was thrilled. Many physicists cringed, feeling it misrepresented the Higgs boson. The Higgs boson doesn't have any inherent religious connotations. It's a fundamental particle, a crucial piece of the puzzle. For many, God particle felt like a cosmic PR mishap, a catchy but misleading moniker that trivialized their research. Section 4. Respecting the science beyond the sensational headlines. Despite the concerns of some physicists, the nickname God particle had already escaped the confines of the scientific community and taken on a life of its own. It became a cultural phenomenon, a shorthand way for the public to grasp the significance of the Higgs boson, even if the terminology wasn't entirely accurate. And you know what? Sometimes a little bit of sensationalism can be a good thing, especially when it comes to piquing public interest in science. The God particle might have made some physicists cringe, but it also sparked countless conversations about particle physics, inspired a new generation of aspiring scientists, and reminded us all of the awe-inspiring mysteries that lie at the heart of our universe. So, while it's important to acknowledge the concerns of those who find the nickname misleading, it's also worth recognizing the role it played in bringing complex scientific concepts to a wider audience. After all, science isn't just about equations and experiments, it's also about sharing our discoveries with the world and inspiring others to join us on the journey of exploration. The discovery of the Higgs boson wasn't just the end of a decades-long search, it was the beginning of a new chapter in our understanding of the universe. The Higgs boson, God particle or not, has opened up a Pandora's box of new questions and avenues for exploration. Physicists are now using the Large Hadron Collider and other experiments to study the properties of the Higgs boson in more detail, hoping to unlock the secrets of its interactions with other particles and its role in shaping the universe as we know it. The Higgs boson is a gateway to the unknown, a portal to a realm of physics beyond the standard model. It's a reminder that for all our scientific advancements, we've only just scratched the surface of understanding the fundamental nature of reality. And that, my friends, is a truly exciting prospect. So there you have it, folks. We've journeyed from the subatomic realm to the vast expanse of the cosmos, all in pursuit of this elusive and fundamental piece of the universe's puzzle. the Higgs boson. We've delved into the weird and wonderful world of particle physics, explored the mind-bending concept of the Higgs field, and witnessed the culmination of decades of scientific ingenuity and collaboration at the Large Hadron Collider. The discovery of the Higgs boson, while a monumental achievement in its own right, is not the end of the story, it's just the beginning. It's like finally finding the key to a secret room, a room filled with untold wonders and mysteries just waiting to be unlocked. This tiny particle with a name that sparked both curiosity and controversy has fundamentally changed our understanding of the universe and opened up new avenues for exploration that we're only just beginning to grasp. But what does it all mean? What are the implications of this discovery for our understanding of the universe and our place in it? The Higgs boson, despite its diminutive size, we're talking smaller than an atom, folks, smaller than you can even imagine, is a true giant in the world of physics. It's the linchpin of the Standard Model, the missing piece that completes our picture of the fundamental building blocks of matter and the forces that govern their interactions. Without the Higgs boson, the universe as we know it simply wouldn't exist. There would be no atoms, no stars, no planets, and definitely no pizza deliveries. The Higgs field, of which the Higgs boson is a manifestation, is what allows particles to gain mass, to clump together, and to form the structures we see all around us. Think about that for a moment. This tiny invisible particle is responsible for the very fabric of reality, for the existence of everything we can see and touch, everything we are. It's a humbling thought, isn't it? The Higgs boson is a reminder that the universe is full of surprises, that the smallest things can have the biggest impacts, and that there's still so much we don't know. The discovery of the Higgs boson wasn't the end of particle physics, it was just the beginning of a new and even more exciting chapter. With the Standard Model now complete, physicists are turning their attention to the vast unknowns that lie beyond its boundaries. They're using the Large Hadron Collider and other experiments to search for new particles, to probe the properties of dark matter and dark energy, to unravel the mysteries of the early universe, and to test the limits of our current understanding of physics. It's a quest for knowledge that knows no bounds, a journey of exploration that will take us to the very edge of what's knowable. And like all great scientific endeavors, it's a journey that's full of surprises, setbacks, and unexpected discoveries. The Higgs boson has given us a glimpse into the universe's inner workings, but it has also raised more questions than it has answered. And that's a good thing, because it's those unanswered questions, those nagging mysteries, that drive us to explore, to innovate, and to push the boundaries of human knowledge. The study of particle physics is, in many ways, a study of contrasts. It's about exploring the infinitesimal to understand the infinite, about delving into the realm of the smallest things to comprehend the vastness of the cosmos. It's about recognizing that we are all connected, that the atoms in our bodies were forged in the hearts of stars, that the very fabric of our being is intertwined with the grand cosmic dance of particles and forces. The Higgs boson, this tiny, fleeting ripple in the Higgs field, is a reminder of this profound interconnectedness. It's a testament to the elegance and complexity of the universe, to the fact that even the most seemingly insignificant things can have a profound impact on the grand scheme of things. The quest to understand the Higgs boson and its role in the universe is a quest to understand ourselves, our place in the cosmos, and the fundamental nature of reality itself. As we stand on the precipice of a new era of discovery, with the Higgs boson as our guide, we're filled with a sense of wonder and excitement. What new mysteries will we unravel? What new particles will we discover? What new laws of physics will we uncover? The future of science is bright, and the possibilities are endless. But one thing is certain, the journey of exploration is just as important as the destination. It's the thrill of the chase, the joy of discovery, the satisfaction of unraveling the universe's secrets one by one that truly makes science so captivating. So, the next time you look up at the night sky, remember the Higgs boson, that tiny particle that changed everything. Remember the power of human curiosity, the importance of scientific inquiry, and the endless possibilities that lie ahead. Keep asking questions, keep exploring, and never stop looking up. The universe is waiting to be discovered.